Good morning, everyone. Thanks for joining us for today's live session on EV technology, Renesas Automotive Solutions to help you navigate your challenges. This session is brought to you by the team at India's leading automotive events, Commercial Vehicle Forum, Passenger Vehicle Forum, and Two-Wheeler Forum. We have partnered with Renesas Electronics Corporation for today's session. Renesas is a Japanese semiconductor manufacturer headquartered in Tokyo. It has manufacturing, design, and sales operations in around 20 countries. It is one of the world's largest manufacturers of auto semiconductors and microcontrollers. In terms of the agenda for the session, we will start off first with a brief context setting presentation that gives you an overview on the topic, and then we will have two more detailed presentations with live audience Q&A at the end. So before we start this session, I would just like to share a small ground rule. I would request all you attendees to direct any questions you have to the Q&A section at the bottom of your screen. I'm asking you to do the same because it helps us refer to your questions in a more focused manner. Also, you can upvote these questions, which will help us in addressing the most burning topics. So please note, once again, all questions to be entered to the Q&A section at the bottom of the screen. So without further ado, I would like to introduce you to today's first speaker, Mr. Shige Shika Motoyama, who is Vice President, Automotive Asia Account Management at Renesas Electronics Corporation. Mr. Motoyama is someone who has over 30 years of experience in semiconductor sales. We are honored to have him on board today. Over to you, Mr. Motoyama.
Oh, thank you very much. Hello, everyone. Good morning, everyone. So I'm sitting in the Tokyo office, and then thank you very much for joining this event today and taking your time. So today, so we'll have the winning combo webinar. Then we'll share our goods, the best solution for our focus segment in the automotive. Then could you next slide? So already this is a short presentation myself. Then so I joined the NEC and more than 30 years experience in the sales segment, and then also I've been based in Singapore for the 3.5 years since 2014. Then I've been in India several times for this 3.5 years. So today I'm very happy to have this event with the India team. So thank you very much. And then please, next slide. So I'd like to touch upon briefly our history. So basically we have started with the Japanese 3 company, Hitachi and Mitsubishi, then NEC. NEC joined in 2010. Then we became the NEC Electronics Corporation. Then last 3 years we had the 2 acquisition with the US company. One is the Intersil, and second one is the IDT, which is and last year 2019 to strengthen our overall kit solution and to focus severely our market segment. So next slide is showing what we are expanding the business field. One of the major segment we are focusing in the automotive. Then you can see that in the center of this slide, the Renesas is basically competitive in processing technology. And then in order to expand our business field and also in order to provide the best solution to the customer, we strengthen by acquisition the 2 US company, mainly to strengthen the analog and power segment. So today we'll have the 2 sessions to share one of our example and also our direction and what is our strengths and so on. So please enjoy today's event, and any kind of feedback and also the request is welcome. Thank you for your time.
Thanks for the introduction, Mr. Motoyama. Now to kick off the first presentation, I would like to introduce Mr. Shunichi Kairayama, Vice President, Automotive Analog Product Marketing Division at Renesas Electronics Corporation. Mr. Kairayama has around 20 years of experience, and prior to Renesas was associated with the NEC Corporation. We are excited to have him on board today. Over to you, Mr. Kairayama.
Thank you for joining. Today, I will introduce about the Renesas winning combo, especially for the positional sensing with our inductive positional sensor. Okay, this is my selfie. I started my career in 2001 in NEC Corporation, and where I was a design engineer and research engineer for the high-speed and analog IC designs. Just 1 minute, please. Okay. And yeah, after the merger of Renesas Technology and Energy Electronics, I moved to Renesas Electronics Corporation, and now I am a Vice President of Automotive Analog Product Marketing Division, and I have about 20 years experience in analog IC design. And my interest also includes solution level, for example, motor control or product and so on. Okay. So this is the agenda of my talk today. First, I will introduce our analog product strategy, and then I will move to our winning combo solutions. Here, I will explain about the motor control solution with our inductive position sensor. And then I will go into the detail of each component, for example, microcontroller, power MOSFET, and inductive position sensor. Okay. Let me start with our analog strategy. We are a very big company, especially in the automotive microcontroller and SoCs. But now we are strengthening analog and mixed signal products by acquiring IDT and Intersil Corporation. And after acquisition of these two companies, we increased the portfolio of the analog products. And of course, yeah, we also have power discrete devices. Okay, yeah, as I explained, we are very strong in the digital portion, for example, automotive microcontroller and SoC. But yeah, we compensated our missing part by ex-IDT or ex-Intersil corporations. And yeah, currently we have a sensor solution for sensing some position or some pressure, temperature, and so on. And of course, analog devices to drive the MOSFET and so on. And the power management IC, for example, a buck converter, boost converter, or linear regulators, we have also such kind of solutions. Okay, this slide shows our analog and power product lineup. Here, the horizontal axis shows our application area, and the vertical axis shows where the product coming from. By acquisition of Intersil Corporation and IDT Corporation, we increased our analog portfolio like this. For example, we have power management IC for wide area of applications, and video signaling solutions, and timing IC to provide the clock signals to the SoC or microcontrollers, and the radar and radar solution, and the wireless charging solution for the cell phone. And here we will focus on the XCD solution. After my session, Nashket Haras will provide the whole XCD inverter solution, including several components. But today I will focus on the position sensing solution. Okay. Let me introduce our winning combination. Winning combination is a kind of a reference design or solution which includes our microcontroller or SoC and analog and power products, and which can help customers to accelerate their designs to get much faster. So it can boost the time to market, or can reduce the development cost and so on. Okay, and the combination basically consists of our SoC or microcontroller and the power MOSFET or IPD or gate driver or some kind of video signaling solution or power management solution and the sensing solution and so on. And these parts are coming from ex-Intersil Corporation or ex-IDT Corporation. Okay, these figures show some examples of our winning combinations. If you visit our web page, you can find several combinations. For example, instrumental cluster, or battery management, or domain controller, motor controller, and so on. So please visit our homepage. Okay, let me start the detail of the motor control solution. So this is the typical block diagram of motor control. It basically consists of a microcontroller and a gate driver and some MOSFETs and a position sensor. And today, I will recommend you to utilize our inductive position sensor. The application, typical application of the motor control is, for example, traction motor or EPS, electric power steering, valve control, fan, pump, compressor, and so on. And benefit of our solution are, for example, lower cost, lighter and thinner than resolver solution. Now I'm talking about our position sensor benefit. So our position sensor has some benefits of lower cost, lighter, and thinner than resolver. And the position sensor can be integrated on the PCB. On the other hand, resolver or some other sensors cannot be integrated on the PCB. So our position sensor can reduce the cost by mounting on the PCB. And this sensor also immune to the magnetic field. So if you put the position sensor very close to the motor, there is a very strong magnetic field. So, and sometimes it causes the malfunction by the strong magnetic field. But our position sensor is very immune to the magnetic field. It's a kind of a strength of ours. And with this solution, it is very good for high density integration with the motor. So because it's very small, thin, light, and strong to the magnetic field. Okay, the solution is now available with some different designs, so you can easily start with our solution. The left one shows our microcontroller starter kit, which includes the software for the field-oriented control and the motor control GUI like this. And it also includes the Green Hills evaluation license and IAR starter kit edition, and our CS Plus, which is integrated development environment license. And this board also includes a microcontroller, including gate driver and MOSFET and brushless DC motor and power supply module, and E1 emulator here to connect between the microcontroller evaluation board and your PC. The right side figure shows our starter kit for the inductive position sensor. Here is the inductive position sensor, and this PCB pattern is a kind of a coil design, which is used to detect the position of the rotor. So this evaluation kit is already available through our sales persons or Mauser and so on. So you can easily start with our solution kit. Okay, let me explain the detail of our product. So the first is microcontroller. So we have a very strong microcontroller lineup. The benefits are here. For example, we have a very scalable lineup, single core, dual core, or multi core architectures from 120 megahertz to 320 megahertz for frequency. And currently, we are using 40 nanometer MOS flash technology for automotive grade, and it can tolerate with high temperature. And 28 nanometer process will be soon available. And regarding to safety, we will cover ASIL-A to ASIL-D. Okay. And the scalable lineup, the memory range from 512 KB to 8 megabyte flash, as well as the package scalability from 48 QFP to 324 pins BGA package. And regarding to security, our latest microcontroller supports the security module with the hardware extension or hardware module. And yeah, quality, we have the best quality in the world. And you know, Japanese automotive manufacturers are very severe about quality, and we have #1 share in the very severe automotive market in microcontroller. Okay, this one shows our roadmap of microcontroller. Currently, G3M and G3MH core are available, and today I will introduce about these microcontrollers, as well as low-end 16-bit microcontroller RL78 series. Currently, the G3M core with 240 MHz CPU, or G3MH with 320 MHz CPU core available, as well as lower cost versions, RH50F1 series and 16-bit microcontroller. Okay, this table shows the comparison of our microcontroller, which are suitable for the motor control. In the low end, we recommend RL78 series. It's a kind of a 16-bit CPU with 32 MHz clock frequency. And the lowest cost microcontroller with a 32-bit core is RH850F1 series. And it has 120 to 240 MHz CPU core, and it has generic timer and so on. P1 series has a lockstep core. It is a very good solution for the functional safety, and it also has a suitable timer unit for the motor control. This one is a dedicated timer for motor control. And C1 series has a vector mass accelerator, which is very strong mass accelerator to calculate the vector mass calculation for the FOC. And it also has a RD converter. And C1MS series has extended clock frequency, 320 MHz, and it can support HD. Okay, and here's some benchmark results of our several CPU cores. So here RL78 and RH850F1 series are generic microcontroller for the general purpose, and it takes time to calculate the speed PI control, including vector mass calculation, and F14 takes 120 microseconds to calculate this control unit. And with our 32-bit microcontroller F1 series, it can be greatly reduced. But with our C1 series, the microcontroller has greater power, so the calculation time will be reduced about 1/3. And with our vector mass accelerator EMU, with this EMU, the vector mass can be performed with the hardware accelerator, so that the calculation time can be reduced about the half of the processing with the CPU only. Okay, let's move on to the MOSFET. Here we have basically two lineups of MOSFET. One is ANM1, 2, 3 series. This is designed for 48-volt system with the voltage strength of 80 to 100 volt, which is a very suitable solution for the 48 battery system. And for the lower voltage, we have ANL2, 3, 4 generations. It is very suitable for 12-volt applications with the voltage strength of 40 volts. Okay, this is the benchmark of our low voltage MOSFET ANL345 series. And with the latest generation, the structure of superjunction and cell pitch will be improved. So cell pitch are shrunken. So the on resistance can be reduced. And typically with the TO236 package, on resistance can be reduced from 0.72 milliohm to 0.56 milliohm, like this. Okay, this page shows the medium voltage MOSFET, which is suitable for the 48-volt applications. For example, typically traction motor for two-wheelers, three-wheelers, and so on. Of course, it includes the BSG or ISG, mild hybrid system. It is very popular in European market. Okay, the on resistance is slightly higher than the low voltage MOSFET because of the higher voltage strength. But in our latest generation, it can be reduced about 20 to 25%. You can reduce the number of parallel MOSFETs by using the latest solution. Okay. This page shows a benchmark. With our latest solution, the on resistance, normalized on resistance is steadier to the competitor's solutions. And our strength is low on resistance. And we can handle the custom bare die if you need bigger MOSFETs, and if you need some current sensing solution with current sensing MOSFET or temperature sensing diode are necessary, we can handle such kind of custom bare die. Okay, let's move on to my main topic today, inductive position sensor. Okay, this is the overview of our inductive position sensor, which can be consist of only PCB patterns. And here is a PCB coil, and the metal pattern can sealed or through the magnetic field. Then the inductive position sensor IC can detect the position of the rotor. And the main benefit is very cost effective. There is no magnet or no resolver. So the cost is cheaper than resolver or magnetic sensor. And the thickness is 5 times to 10 times thinner than the resolver or magnetic sensor. And twice to 100 times lighter than resolver. And it is very strong or robust to the Story field. Okay, and the usage of this position sensor is very wide. For example, you can use it for the rotational sensor, for example, for the motor position sensing or control dial and so on. And narrow angle is also covered, for example, for the gas pedal or gas handle or valve control and so on. And the linear radar is also a possible solution. And for example, the application is liquid gauge, for example, oil gauge or fuel gauge or water gauge and so on, or gear setter and so on. Okay, and another benefit of this position sensor is it has a flexible multiplier from mechanical angle to the electrical angle. If your motor is one pole pair, you can put the metal disc like this. If the disc rotates once, the electrical angle rotates 360 degrees. And if your motor is two pole pairs, you can put design the disc like this. And if the disc rotates once, the position sensor outputs the 720 degrees. And even if your motor is 4 pole pairs, it is even the same. If the motor rotates once, the position sensor can detect the change of the angle of 40 degrees. Yeah. Okay, here is another benefit of our position sensor. It is a flexible mounting. So you can put our position sensor in the end of the shaft like this, and it is the same mounting method with the magnetic position sensor. And you can also put our position sensor in the through shaft condition. It is like a resolver position sensor. And the final one is side shaft mounting. It is very easy for the maintenance or assembly. And with a resolver or magnetic position sensor, this mounting is not possible. So this is our strong benefit. Okay, let me summarize my presentation. Renesas will address many combinations contribute to reduce your design effort and to shorten time to market. And we proposed a motor control solution with a novel inductive position sensor. The benefits are below. Position sensor can be integrated on PCB, good for high density integration. And low cost, thin, lightweight, and magnetic immune are our strengths. And flexible mounting around the motor is also a benefit. And the flexible angle multiplier. Angle multiplier means the multiplier from electrical angle to mechanical angle. And this is also very flexible, and this characteristics is not available in the magnetic position sensor. And we will provide appropriate microcontroller power MOSFET or regulator for the motor control as well as the position sensor. And please visit our website, and here several winning combinations as well as inductive position sensor and motor control are available. Thank you very much for your attention.
Thanks for the insightful presentation, Mr. Kairayama. Now for the next presentation, I would like to introduce Mr. Nachiket Hardas, Principal Manager at Renesas Electronics India Private Limited. Mr. Nachiket has around 20 years of experience with a history of working in the semiconductor industry. Prior to Renesas, Nachiket was associated with Hitachi India and Hynetic Electronics. Please join me in welcoming Mr. Nachiket.
I hope you all are safe and healthy. Thank you for joining this session on low voltage inverter solution for battery electric vehicle. Let us have a quick look at the topics that I will cover today. So we will be doing xEV system overview. We start our solution by showing you what is our offering, and we'll focus on the low voltage inverter reference design available from Renesas for battery electric vehicle. Further, I will break down the inverter reference design and introduce you all to the various Renesas components that are used in achieving this inverter system, such as microcontroller, PMIC, and gate driver IC. So this is the overview of xEV system containing onboard charger, DC-DC converter, battery management system, and inverter. For the scope of our presentation, we are going to limit our discussion to inverter. However, as you can see that we have plethora of products that are targeting electric vehicle segment, and we will be further introducing all these things to wider audience moving forward. Additionally, all the details of these products are also available through our website. So please feel free to visit our website, renesas.com, and find out a suitable product for your use case. So to start off with the low voltage inverter reference design, let me first define what is low voltage. The inverter reference design power stage is designed for a 48-volt battery pack, and hence labeled as low voltage. We do have a high voltage inverter reference design available for the traction motor systems for four-wheelers that we collaborate with our other regional counterparts like Japan and Europe to bring that technology to India. However, for the low voltage inverter reference design, please note that this can be scaled up as per the customer specification. So we would like to hear your requirements and then discuss the power architecture case by case basis. So let me jump into a bit detail about the reference design. This slide gives you an overview of low voltage EV inverter solution for motor controller. With the reference design made for real motors, you can start evaluating your use case without waiting for custom hardware. This helps you complete your POC within the shortest time possible to win a project. And we define specifications of our reference design typically based on the customer feedback. And our objective is to help address customer pain point during development of their system. Therefore, you will notice that many of the vehicle interfaces typically needed are provided in the reference design, such as support connection for vehicle IOs, brake sensor, accelerometer, switch and drive mode, switch gear settings, along with PWM output for digital cluster and maybe external thermal management system. We also provide various communication interfaces such as CAN, LIN, RSEN ports on the reference design. Using these interfaces, connection with ride-by-wire throttle or brake can be achieved. CAN ports allow access to other ECUs on the vehicle or any other sensor on the vehicle. And additionally, we have provided one CAN FD isolated port in order to accept some of the settings or commands from the vehicle control unit or any other OBD kind of a function that can be implemented. So of course, the end system may be subset of our reference based on the specification. But additionally, our reference design provides you with an image of system cost and help you plan your hardware and software development in the shortest time possible, because it gives you an idea or overview into your own application use case. Now, being a leading automotive semiconductor supplier, we have many AEC qualified products for applications such as motor control. These components, when used in combination, offer implementation of functional safety goals. I will cover this as we look into the parts used in the reference design further down the presentation. And we are using RH850C series microcontroller designed with specific IPs on chip to support motor control application. We have MOSFET gate driver ISL 78434, which has adaptive dead time function to ensure safe operation of the inverter bridge. And we have RAA series power management IC that ensures microcontroller is supplied with necessary power during normal and adverse conditions. Finally, we also use intelligent power devices for controlling external 12-volt bus net loads. The IPDs are protected high-side switches and allow load monitoring via ADC on MCU. So this is one of the critical factors to implement functional safety, that you need to monitor all the IOs and continuously perform checks on their functions. Now, looking at the reference design, as we know, it is very difficult to have single reference design fitting everyone's requirement. Therefore, we have invested past 3 years developing or supporting customer requirements. So let us have a look at that now. So we started off our development using the RH850 F series device, targeting 5 kilowatt continuous power and peak power of 8 kilowatt for a battery electric vehicle. Now, as introduced by Kariyama-san, there are various series of devices that are capable of doing motor control from our entry-level 16-bit to 32-bit. So as we heard more about requirements from the customer, we prepared a scaled-down version of the inverter design using our automotive-grade 16-bit microcontroller RL78. And this was targeting lower wattage traction motor requirements. And we've also scaled up our design based on RH850 F series to all the way up to C series, looking at the performance demand of the electric vehicles in India. And we use AEC qualified products in our reference design. So it makes the designer that saves time. It makes their life that much easier. And our reference designs have been adopted by customers for applications like e-cycle, which is targeting roughly around 250 watts of power. Then a 1 kilowatt e-rickshaw controller, and also 3 kilowatt continuous power two-wheeler controller. So these are not just the paper designs, but actually adopted by the customer. So let me show you the test result of a 2 kilowatt drive developed by the customer. So this is a test result of an electric auto rickshaw 2 kilowatt drive. We have designed and adopted by a customer. So for a 2 kilowatt drive, we achieved the inverter efficiency above 95% and system efficiency above 80%. So please note, as you may know, that system efficiency is also dictated by the motor efficiency. So the overall system efficiency looks lower, but if you look at the typical performance figures for a 2 kilowatt load, then we have achieved around 97 to 98% of inverter efficiency using our reference design. So now, as we know the reference design and its flavors, allow me to introduce the RH850 product lineup for automotive applications and RH850C series MCU to you, and why we need this MCU for EV or motor control application. So RH850 lineup is offered by Renesas based on applications. Because we understand the system level requirements, we have tailored our MCU lineup to meet application specific implementation. So for example, E series is for powertrain, P for chassis, R for airbag, D series is for instrument cluster, F series is for general body, and C series is for the HEV or EV application. The RH850C series device is suitable for HEV EV motor control because of the specific IP on chip to improve performance and reduce footprint by high peripheral integration. So let us have a look at the IPs that are integrated on C series microcontroller. So first is EMU. EMU is embedded motor control unit. It is an arithmetic processing unit for vector calculation. Now, this block diagram is a typical motor control diagram using vector control or field-oriented controls or PMSM motors. The green area is axis transformation, which is many calculations. So you can imagine that these transformations are very heavy for the CPU to do all the calculations in a given period of time. But EMU calculates these transformations by dedicated hardware accelerator, and the CPU time is reduced 1/7, so you can freely utilize the CPU power with your own software. The performance benchmark figures which are shown here are for the RH850 CPU only, which do not have EMU or which has higher performance core. And then there is a RH850 CPU with EMU, like a C series device. You can see the computation is down to 0.8 microseconds, and some of the competitor motor control hardware require at the best 6 microseconds to close the computation loop for motor control requirement. So you must be wondering that whether this provides me a flexibility, whether the programmer has got control over this hardware IP or not. So let me show you some of the examples of EMU3 use case, which demonstrate the flexibility to interrupt and access various IP blocks within the EMU3. So example one is customers using their own algorithms. They can break each process down into smaller pieces and choose the functions that they want. In the example 2, we can see that each EMU control IP can be activated by software. Therefore, each control IP of the EMU can work as a math library in the user program, but the math library, you can imagine, is implemented in the hardware. So if you look at a detailed block diagram on the slide on the right hand side, then you can see that the PWM IP, which takes in the current and the angle information, can have an interrupt in order to do some software processing, and then based on the customer's own algorithm or model, they can load certain output to the wave modulator directly, which then performs limit checks, duty checks, and detent compensation before it outputs the PWM to the inverter bridge. So to conclude, I'm sure you will agree that with EMU IP, you achieve higher performance while being flexible for motor control technique implementation. And let us look at another IP that the C series incorporates now. So this is a resolver to digital converter block diagram, and our microcontroller RH850C series integrates this hardware inside the chip. Because there are so many parameters you have to set, RDC is difficult to master. It's a complex mixed signal IP, which involves analog as well as digital control sections. And to ease your life, what we do is we provide a reference software for on-chip RDC, so you can easily learn how to use our RDC. And we have a strong collaboration with world's #1 resolver maker, Tamagawa Seki. These are holding more than 80% market share for the resolver implementation. They have their own chip, which is depicted here in the block diagram, which is normally an external component. So what we have done is, by collaborating with them, we have integrated this IP also inside the MCU. So there is no need of an external RDC. Therefore, this RDC integration brings ease of use and reduced BOM cost to our customers while offering a smaller footprint on the device. This lets you prepare a very compact inverter design or a control card for the inverter, which can be fitted inside the motor. So if you have an idea, something like drive built inside the motor, then you should seriously consider RH850C series device. Finally, with the integration of EMU and RDC integrated on chip, many of the motor control engineers would be wondering what are the output waveforms that are possible with the modulator that is available on chip. So these are various output waveforms that are possible through the hardware modulator. So you have sine PWM, you have third harmonic injected PWM, two-phase SVM, and various discontinuous mode conduction waveforms. All these are possible. So given the time, I'm not going to go into details of each of them, but this is just to give you an overview of whatever you can think of is possible. One output waveform which is required for very high-speed motor control is a rectangular waveform. So that is also provided through the EMU IP through a dedicated rectangle IP, which is not shown in this slide, but rectangle IP is a direct output available for all the 6-phase PWM. So following the C-series introduction and its IP discussion, allow me to introduce you to our PMIC for RH850. So this is the block diagram of our PMIC with C-series microcontroller. The power supply and timing requirements are complied for the RH850 C-series devices, but they are also compatible with other RH850 devices. The most important feature of the PMIC is the self-diagnostic function with built-in self-test. So this allows you to achieve functional safety requirements. And additionally, you can see that we have lower external component count, just 17 parts only, and we can achieve a smaller footprint on the PCB. Because of the high frequency DC-DC converter, you can see that the size of the inductors are also very small. Okay, so let us have a look at a bit details of the PMIC specs. So the PMIC focus on providing 3 main benefits: ease of use. PMIC has 2 DC-DC converters for the CPU core and digital section, 3 LDOs, and 2 trackers with internal power stage for peripherals. Now the input voltage range is from 6.3 volt to 26 volts and is load dump tolerant. Energy efficiency is achieved by dual DC-DC converter architecture, and there are various fault diagnosis functions which are on chip, such as advanced window watchdog timer, which is controllable, and handshake can be done with the microcontroller to ensure that the microcontroller is operating safely. There are additional under voltage, over voltage detection, overcurrent protection for all the regulators that are present. There is also a thermal shutdown, which always keeps the device in safe operating region, and also repair reports in case of such a condition occurring. Many fail-safe and self-diagnostic functions can be monitored through the SPI by communicating with this PMIC. And if you are wondering if you can monitor each of the internal voltages, then that's also possible through the built-in analog multiplexer. So there is a mux out available from the PMIC, which can be connected to the ADC and monitor each of the voltage outs. So thereby you can achieve a very good functional safe environment using the combination of PMIC and RH850 MCU. The next component in our inverter reference design is the MOSFET driver. So Renesas' new family of automotive half-bridge drivers increase our portfolio by adding higher peak currents. So you can see that the peak currents are 2 to 4 amperes and help achieve better efficiency and lower EMIs. Now, one of the key tech that is included on this device is adaptive dead time control. This is achieved through the gate sense technology, which is unique in these automotive gate drivers. This prevents shoot through and improves the efficiency by minimizing the dead time. Additionally, if you look at the block diagram, you can notice that the on and off timing can be individually controlled by the series gate resistance, which are defined for the high side and low side independently. So considering all these device options that are provided, you have the flexibility to use these gate drivers into many system variants. So not just device available with independent high and low side in low PWM input, but there are also devices available with single PWM input with enable pin, and the dead time is managed by the device through its own internal logic. So this brings me to the end of my presentation. Thank you very much for your patient listening. The links are available through presentations that are shared. You are free to visit our website renesas.com and find out more about Renesas products. And I think thank you very much. I would like to continue on the Q&A session. So let's have a look at the Q&As.
Nachiket,
Yes,
I
thank you.
your team has been answering a lot of these questions already, so they have been quite proactive.
Okay.
I think there is only one pending question of the CP SR equal to 4. I don't think that's been answered, which I believe is the constant power speed ratio is equal to 4. I think somebody.
No, I think I will have to give it a skip as well, because I would need to know
okay,
what
you would.
Yeah.
Okay, you would need to check internally.
Yeah.
Okay, so otherwise, people have been asking for the presentations. Please note that we will be sharing the presentations post the conclusion of the event. You can drop me a line at rohit@threefold.in. I'd be happy to share the presentations for today with you guys. And I think the Renesas team has been quite active in terms of answering the questions in the Q&A section. Unless the Renesas team feels that they would like to address something live, I mean, you guys can just let me know. Otherwise, I will conclude the session. Vivek from Renesas team. I mean,
FW is, I think FW is flux weakening. So yeah, flux weakening has been achieved in our reference design and the software. So this is done. So I'm assuming FW is flux weakening. Any thoughts on battery leasing model? Okay, sorry.
Yeah, so yeah, a lot of people have been asking, in terms of the battery leasing model, is that going to give an impetus to EV in India? So that's something that few people have asked.
Yeah, there are various business models that are in discussion for quick adoption of the electric vehicles. So battery leasing model is one of them, I believe. It works out on the economics for the customers. Yeah.
Okay, sure. Okay, so I think more people are asking in the Q&A now.
Yeah, we can wait for a couple of minutes and see what all questions are coming up. Need more details about the PCB requirement and other hardware and software features of the inductive position sensor. So Let me take this question. Jagrut Dave has asked, need more details about PCB requirement and other hardware and software features of the inductive position sensor. So we do have a tool which we use for the PCB design. So based on your use case and implementation of the inductive position sensor, whether it is a linear or a rotary or arc-based implementation, our PCB design tool can simulate the application and provide you with the optimum design criteria. The PCB design tool also generates a Gerber for you. So this is the support that we extend to our potential customers. So please discuss with sales marketing on your requirement and see how we can use inductive position sensor in your use case.
Okay. I think the next question, Umesh has asked, any reference solution on fuel gauge using inductive position sensing? Is that something you would like to do?
Yeah, I mean, customers are using this in their design. So unfortunately, we cannot share all the details, but it is used in fuel gauge sensing. And one of the advantages that customer found using the inductive position sensor is providing the isolation with the fuel sensor. And it was implemented on a arc kind of sensing.
Okay. And the next one is, does Renesas provide thermal management solution for EV batteries?
At the moment, no. We do not have any reference solution for thermal management, but we do have a solution for battery management system.
Okay, sure. And then in terms of, can you explain the ASIL levels that somebody has asked?
Okay. So ASIL is automotive safety criteria for different applications that is defined. So A being the lowest and D being the highest. This is also implemented at the semiconductor level as well as at the system level in the automotive domain or the ECUs. For traction motor, usually in India, people are asking for ASIL-C and ASIL-D, which is the highest level of safety. And it is mandatory for traction motor because it involves life. You are driving and you don't want the drive to fail in the middle of the road and stop the vehicle, right? For applications like cluster, maybe ASIL level B is applied and so on. So it's a wide topic. Functional safety is a very wide topic, but this is in brief. Yeah.
Okay, sure. Then maybe we can answer, somebody's asked, can we calculate the total memory consumption and cache memory for runtime data to check the sinusoidal commutations value and computed feedback angle under PLDC algorithm?
Can we calculate the total memory consumption and cache memory for runtime data? Yeah, I mean, Mr. Pramod, from whatever we have implemented as part of the monitoring functions, we do output certain vehicle parameters or the drive parameters through the CAN port. But if you are saying that you want to have a storage of runtime information of a drive and then later on plot it on external tool to notice how the drive has performed and so on and so forth, then you would need to implement external memory either through a NOR flash or a SD card where you can dump all the runtime information and have a history stored for how the drive performed.
Okay. Okay, so somebody has asked, does Renesas plan to produce semiconductors in India? I mean, they have asked something like that. I don't know if that's...
Yeah, that's a question. At this moment, we do not have such direction or information from the corporate.
Okay, sure. Let's move on. Then somebody has asked about your BMS solution. Does it allow for charging batteries at different voltages For example, charging a 48-volt battery from a 75-volt charger?
Yeah, typically a battery charger is a constant current charger, so we should be able to manage this. But all the details of the BMS solution, maybe we will have a separate webinar on the BMS as a solution.
Absolutely, we can do that. I think we've answered all the questions. I believe. Okay, so we've got one more for FOC based controller. Do you have any application to understand driver usage pattern?
Okay, so if I interpreted this correct, Amal Shinde, you are saying driver is this vehicle driver, like I mentioned just a few minutes ago that we do not have any such application, but you can store some of the critical parameters of the FOC controller into the memory to notice how the driver is riding the vehicle maybe.
Okay. Okay, so somebody has asked Naresh Neelkantan that during high-speed cornering, you could reverse the motor on the inside wheel of the corner to achieve reverse lateral control. So wanted to know how fast we can reverse the motors for high-speed scenario.
Okay, I think I'll have to give it a skip. I do not have a ready answer for this.
Okay, so okay, fair enough.
I'm not sure. Kairiyama-san can take this because it's
Kairiyama-san, would you like to answer that? I mean, somebody has specifically asked your views on that.
Yeah, let me repeat the question.
Okay, you want me to repeat the question?
Oh, okay.
Okay.
The question is, whether we can rotate the motor reverse side. Is it right understanding?
Yeah, so he's asked during high-speed cornering, you could reverse the motor on inside wheel of the corner to achieve reverse lateral control. So wanted to know how fast we can reverse the motors for high-speed scenario.
I think it's possible and it's not difficult because just the direction of torque or speed of the motor can be easily changed. So technically, it's possible.
Okay, it's possible. Okay, great. Okay. Okay, I think we have answered all the questions, and we are, at the end of our time as well. So I'll quickly say, the exit speech. Okay. Thank you all for joining us for today's live session on EV technology. I hope you enjoyed this session and found it useful. Firstly, I would like to thank all our speakers for taking out time from their busy schedule. We really appreciate your support. Secondly, I would like to thank a wonderful audience for their inquisitiveness and their attention. We received a lot of questions, a lot of active participation. Thank you so much. And in case, if you feel that something has not been answered or you still have some queries, please feel free to drop us a line at rohit@3fold.in. We would be happy to address those questions. And like I mentioned, we would be sharing the presentations with you as well once the session is concluded. Lastly, I wanted to take this time to specially thank our partner, Renesas Electronics Corporation, for supporting this session. Thank you so much, means a lot. And thank you all for joining us once again. And we will see you next for our upcoming session on tractor and farm equipment on 17 September 2020. Please stay tuned. Thank you so much. Goodbye.